Hello everyone. Previously we installed Microsoft SQL Server Express Edition, which is the free version of Microsoft SQL Server and SQL Server Management Studio into our computer. In this video, we will connect to the SQL Server Express and learn the basics of SQL using the SQL Server Express and SQL Server Management Studio. So this is Object Explorer, which uh, displays the servers and databases and their objects in a hierarchical form. There are some databases which are created at the time of installation. However, you can create your own databases, and to do that you right click here and click on the new database, and in the database name you can enter your database name, for example tutorial db, and uh, here you can select the path of your database. We will keep the default location and then simply click on the OK button, which will create the database. Our database has now been created, which is listed in the databases folder. Once the database has been created, the next step is to create some tables. There are two ways you can create a table. One is to right click here and select new and then table, and the other is to use a query. The advanced users prefer to use the query, but you can also use the new table wizard. Here you must define the name of the column, its data type, and whether it allows null data or not, which means that this column accepts blank values. So our first column will be customer ID and its data type will be integer, and this will be a primary key, which means it will be unique and it will be incremental. Therefore, we will set the identity specification to yes and identity increment to 1, which means every time a new row is entered, the customer ID will increase by 1, and identity seed means the initial value will be 1. That means the customer ID of first customer will be 1. A primary key field will never accept a null value, and all the values in this column will be unique as well. Our second column will be the first name of our customer, and the data type will be characters with variable length, but maximum length will be 50 and null values will not be allowed. The third column will be last name. Again, same data type as first name and no null values. The next column will store the name of the city. The data type will be the same as first name and last name. Null values will be allowed, and the next column will save the name of the country. Same data type and null values will be allowed. Now we can press the Ctrl S button and save this table. Let's call this table customers and press OK. Refresh the tables folder, and now you can see the table along with its all columns, and you can now close this table designer. This is how we design a table using the table designer. We can also design a table using the query, and to do that we have to write the SQL code. For example, let's create a new table, create table orders. This will create a table named orders. The columns will be defined inside these brackets. Our first column will be order ID. It will be an integer and primary key. And identity with one incremental value and one seed. Each column will be separated using a comma sign. Now if you remember, in the customers table we created the same column by the name of customer ID, and we defined it as primary key, and we set its identity in the same way with one incremental value and one seed, but all these things were done using a designer. However, here we did the same thing by writing SQL code. The next column will be customer ID. This is the same column defined in the customers table, and its data type will be the same integer. However, here it will be a foreign key, and it will be referenced to the customers table towards the customer ID field. This will connect both tables, and with each order the customer ID will be stored, and through which we will identify which order belongs to which customer. Next, we will store the order date as date and total amount as decimal with two decimal places. Now we have defined the orders table, and we can execute this query to create the table. This table should now be created, and we can refresh the tables folder and see the table. Now we can insert data into these tables, and to do that we can close this query and create a new query. We can write an insert command to enter data into the customers table. First we will have to define the names of the columns where we want to enter the data. For example, first name, last name, city and country. Then after the values, we will have to enter the values in the same sequence as defined here. So first we will enter the first name, then last name, then city, and then country. If these are defined in different sequence, then we will have to follow that sequence while entering the values as well. So first value, first name, we will enter John, last name Doe, and city New York, and country USA. And in the same sequence we will enter the next row, first name Jane, second name last name Smith, city London, and country UK. Then the third line, first name David, second name Lee, city Paris, country France. And the last line, Sarah, last name Kim, Tokyo, Japan. And this is how we enter data using the insert command. Now we just have to execute this query, and this data will be entered into the customers table. Remember, for larger data, we do not use insert command in this way. We use bulk insert, or we use another software or utility to insert data into the SQL Server databases. And while entering transactions, we have an interface where the salesperson or someone else enters transactions, and those transactions end up here in the SQL Server database. You have to be careful about another thing, and that is you have already entered these 4 rows into your customers table. But if you press execute again, these 4 rows will be inserted into your table again, so they will be duplicated. So be careful that after inserting data, you close the query and avoid duplicating your data. Now we will enter data into the orders table, and we will again use the insert command. The only thing to be careful about entering data into the orders table is that you have a foreign key, which is customer ID, and you must ensure that the value entered in the customer ID field must be existing in the customers table, in the customer ID field there. So execute the query, and this will enter the data into the orders table. Now that we have entered data into both tables, how can we view this data? To view the data, we can use the select command. Uh, to view all the data in a table, we use select all. The asterisk we use here is for all, so everything will be displayed. Select all from customers. This will display the entire customers table, and as you can see, we entered 4 rows which are all here. Similar way, we can also display information from the orders table using the same command, select all from orders, which will display the entire orders table, and we entered 6 rows which all are given here. To select a specific column or field, we must insert the name of the column instead of select all. So for example, if we want to display only the first names, we will use select first name from customers, and if we want to display multiple columns by their name, we can use first name and last name. So this will display first name and last name from customers. In the same way, if we want to display specific information from the orders table, we can use the name of that field. For example, order date and total amount. So now the query will not display the entire table. Instead, it will display only the specified fields. As you can see, only the first name and last name is displayed from the customer table, and the order date and total amount is displayed from the orders table. So in this query, we displayed specific columns, but we displayed all rows. We can also display specific rows. For example, select all from customers where country is equal to USA. This will display all those rows where country is USA, and select all from orders where total amount is greater than 100, and this query will only display information where total amount exceeds 100. So let's execute this query, and as you can see, only the customers having country USA are displayed here, and all amounts are greater than 100. So in previous query, we displayed specific fields, and in this query, we displayed specific rows. We can combine both and display specific fields and specific rows as well. For example, we display only the customer ID and first name from the customers table where country is USA, and we display customer ID and order date where the orders have total amount greater than 100. Let's also include the total amount. Let's execute now, and as you can see, now the query displays specific rows and specific fields. This section displays fields, and this section after the word where displays specific rows. We can also filter data with partial information. For example, uh, let's select all rows from customers where country is not equal to USA but country like you. So now what happens is that all customers will be selected where country name starts with the letter U. Let's execute this query, and as you can see, both USA and UK start with U, and they are displayed here. In the same way, we can use the percentage sign to display information, for example, ending with letter N. So now you can see that the Japan ends with letter N, and it is displayed here. And we can use multiple characters as well. For example, AN will again generate the same result because Japan ends with N, AN. And if we put the percentage sign both at the start and the end, which will mean that all countries having letter S anywhere in their name will appear in the result. So let's execute, and as you can see, USA had the letter S in the middle, and it appeared in the query result. All of this was filtering information. We can also sort information using the SQL queries. For example, if we select all data from orders table, it will appear like this. But what if we want to sort information, for example, by the total amount? We can use the order by, and after that we need to identify the field by which we want to sort the information. So total amount And after that we also need to provide uh, in what order we want to sort the information. So ASC means ascending, and now the information will be displayed in the ascended order by total amount field. And if we enter the DESC, this will mean that the information will be displayed in the descending order. We can use other fields as well for sorting, and we can use multiple fields as well. For example, we can use uh, order by command to sort data by total amount and then sort data by customer ID, and we will sort information by total amount in descending order and then sort information by customer ID in ascending order, and this will prioritize the total amount, and then the customer ID will be used to sort the data. We can also display top customers or top orders by various definitions. For example, let's select top 3 orders and by total amount. So this will display the top orders by their total amount, and if we want to display the bottom 3 orders, we can make this ASC ascending order, and now the bottom 3 values will be displayed. So it is up to your imagination how you want to use these queries. We can also perform various calculations such as calculating the total number of rows. For that we use the count all and provide the name of the table. So this will calculate the total number of rows in the orders table, and in the same way we can calculate the number of rows in the customers table. And we can also perform these calculations based on various criteria. For example, let's calculate total number of rows in the orders table where total amount is greater than 100. So out of 6, 4 rows have the total amount greater than 100. We can also perform various mathematical calculations such as average, and to calculate the average we must provide the column. So we want to calculate the average of total amount, but if the criteria is provided, uh, the average will be calculated on the basis of that criteria. So here the average of total amount will be calculated where total amount exceeds 100. So this is the average, but if we want to calculate the total average of the entire column, we have to drop this condition, and now the average of entire column is calculated. Similar way we can sum the amount of total amount column, which is 896.5. We can also calculate the maximum total amount, which is 300, or minimum amount, which is 50. So various mathematical calculations can be calculated, and we can use conditions in every case. So if we select where amount is greater than 100, then the minimum amount will be calculated on the basis of that, which is 120. We can also summarize data in SQL tables. For example, if we select the entire table, select all from orders, it will look like this. But what if we want to summarize data based on the customer ID? So we can select the customer ID and suppose we want to sum the total amount. So now we have to provide a group by statement, and we have to tell that the data should be grouped by customer ID. So now we will have a summary of this data where customer matching customer IDs will be summed. So customer ID 1 and customer ID 2, they will appear once instead of twice. And this is how the result look like. The two values of customer ID 1 will be summed together, and same will happen to the customer ID 2. You can summarize data by average or any other calculation as well. So this was all about displaying information using the select command. We can also modify information, and for that we use the update command. So let's first display the information from the customers table. Select all from customers. So this is our original table, uh, customers table. So what if we found out that the city in the customer ID 1 was entered wrong? This should be Los Angeles instead of New York. So we can change this data by using the update command. Update customers that city is equal to LA, where the where clause is very important here, because if you don't provide the where clause, the entire city column will be set to LA. So all these values will be changed to LA. So this is very important. We have to provide the where clause. So in case of this statement, we want to change the city to LA where customer ID is equal to 1. So we will use that customer ID is equal to 1. And let's select the table again so that we can compare both before and after the update command. So as you can see here that customer ID in first row is 1 and the city against that is New York. But after the update command, customer ID is 1 and city is LA. So this is how you use the update command. In the same way, we can also delete data from these tables. So for example, let's select all data from orders table and let's delete the row where the ID, because order ID is 16. So let's delete this row, delete from orders where order ID is equal to 16, and let's select the data from orders table again so that we can compare the original data with the data after executing the delete command. So here is the result. As you can see that the original table had 6 rows, while the table after the delete command has 5 rows. We can also add more columns in our existing tables. So for example, this is our original orders table. Let's add a new column using the alter table orders, add discount, and then we will define the data type, which is decimal, with 5 values, out of which 2 are decimal points. So let's select the data again and let's execute the command. And this is the discount column that we have just created. Now let's enter some values. So we will use the update command, update orders, set discount is equal to, and we will use a formula here where total amount into 0.1. Let's execute this command, and as you can see, uh, before the update command, discount column had no value, and now each value has been calculated and entered into the table. We can also delete columns the same way we can add them, and to do that we use the alter table orders, drop column discount. So this will delete the discount column entirely from the table. Let's execute the command, and as you can see that the discount column has been deleted now. For our next topic, let's first display both tables. And as both tables are interrelated, we can display both information of both tables in a single table using the join command. So to do that, we will use the select command with specific column names. The columns we want to display in the uh, resulting table. So we will select the first name, last name from the customers table, and the order date and total amount from the orders table. So we will use the select command, and then we will enter the name of table followed by its field name. We'll use the left join, which is one of the joins where entire information from the first column is selected, and then the information from second column is populated in the uh, joined table. So the data will be joined based on this criteria, and this is our resulting table. And as you can see, since the customer ID 1 had two results, so both appear here, and the data from first table has been repeated, and this is how both tables are joined together, and the resulting table has information from both tables. Now you can make this change permanently and keep this joint table permanently in the database, and the benefits are limitless. For example, you can uh, write queries on that table and summarize data, perform calculations on that table. And to do that, all you have to do is convert this query into a view. Create view, then give it a name, joined table as. So when you will execute this query, the result will be stored in a view permanently. Our command has been completed successfully, so views are stored here. So open this up and here is your view, and this is just like a table, but whenever any changes to the customers or orders table are made, they will be reflected here automatically. So let's delete this query and write another command, select all from joint table. This was the name of the view we created. So let's see what happens. And as you can see, our view has been permanently saved, and we can perform various calculations or analysis on this view just like a table. You can also see this view in a designer, and as you can see, both tables are connected using a relationship, and you can make changes here as well. Any amendment you make here will be reflected in the view. And finally, just as you can create tables, you can also delete them. And to do that, you have to use the drop table command. Drop table orders. This will delete the orders table. And if you write it drop table customers, this will delete the customers table. And with this, we end our tutorial, and we hope that you like our tutorial on SQL. Thanks.